Here we look at part 2 of the CO2 modeling activity, and in particular I'll show you a little bit about the CO2 modeling environment. First, you have to click on this link that ends with .jir to download this file and open it up. Depending on how your browser works, that will be a little bit different, but it should open up in a standalone Java file with a little cup of Java icon. And the environment opens up like this, and you can resize the window so that it maybe better fits your screen. And here in this first graph, we've got the Mauna Loa data, carbon dioxide data measured from Mauna Loa through 2013. Okay, here's 2010. And the scale on the left goes from 300 to 400 parts per million carbon dioxide level. Okay, now we can run the model like this, and the model simulation is shown in red. Our goal is to get good agreement between model simulation and the observations from Mauna Loa Observatory. Okay, built into the model is the emissions from fossil fuels. If I click on this, I can see the fossil fuel emission graph here from fossil fuel and cement manufacturing. And also built into the model is the carbon dioxide from land use change, often linked with deforestation. Okay. But even with these sources of carbon dioxide going into the atmosphere included, the actual simulation, reset it and run it, predicts a carbon dioxide level that's too high. And so your first task is to adjust this terrestrial sink slider down here so that the model carbon dioxide concentration matches the Mauna Loa observations better. This is the only thing we're doing to tune the model. And so I can adjust this and get a better fit. I won't actually spoil your surprise figuring out what the exact number is that you need for the terrestrial sink, but it's somewhere between 1 and 2 parts per million per year. Okay. Now, assuming that you get a good fit, you can then use this model. So you get a good fit from the 1960 through 2013 data points. And then what we'll do is we'll click on this check for 2000 to 2100 run down here, this little radio button. And this will allow us to go into the future. Now, you'll want to adjust this value here every time you run it so that it always is tuned. The model is always tuned to the appropriate value. And every time you enter something, you have to use the enter key if you don't use the slider. If you use the slider, it goes in automatically. But if you don't use the slider, you have to press the enter button. If it's highlighted in bright yellow like that, that means you haven't hit the enter button. Okay, and now I'll go ahead and run this into the future. And this tells me what the future concentration of carbon dioxide is according to a business as usual scenario. In the business as usual scenario, the emissions of carbon dioxide grow at a rate of 2.7% from 2013 to 2030. Okay, that 2.7% is the average growth rate in percent per year of emissions from the year 2000 to 2013. Then the growth of carbon dioxide emissions, or another way of looking at it, the growth of fossil fuel use, is reduced to 2.3 from 2030 to 2050, then 0.8 from 2050 to 2080, and then finally a growth of only 0.2% per year from 2080 to 2100. This is a business as usual scenario. This is an assumption that the only control on carbon emissions in the future will be economic considerations. No environmental considerations at all. So this is like the kind of a pessimistic view of the future. We can alter this and look at different growth rate scenarios. But first, let's see what the future graph looks like. Again, the carbon dioxide emissions in gigatons of carbon per year grow, in this case, through 2050. Then the growth is continued growth, but much slower from 2050 to 2080, and then a very gradual growth. Okay, but what we really might want to do is we might want to get a growth in emissions of 0. So let's see what 0 looks like. I'll put 0, enter, 0, enter, 0, enter, and 0, enter, and see what that looks like. Okay, in the 0 emission growth scenario, the carbon dioxide emission goes up to 10 gigatons of carbon per year and then stays flat, constant at that level. So any new energy demands after 2013 will come from alternative energy sources. Okay. So if I reset this, and again, I'll run this to about what gives a good fit into the data. Okay, and then I'll check to go into the future and see what the 0 emission growth scenario looks like. Again, notice how I put 0 and then I have to hit the enter button. 0, enter button. 0, enter button. And now, again, for the 2000 to 2100 time period, I had to check this radio button down here. And I run this into the future. So the 0 emission growth scenario, the carbon dioxide level will go up from about 360 in the year 2000, 369 I believe, up to almost 600 parts per million. Notice that this, 0.4, 0.5, 0.6 times 1,000 is 400, 500, 600, 700. Okay, so even though we allow the emissions we don't allow the emissions to grow at all, the carbon dioxide level will continue to grow throughout this century. Okay, this should give you a pretty good start. Good luck.